Risk assessment is a systematic process to identify, evaluate, and manage risks associated with hazards. It consists of several key steps. Hazard identification. Determining what types of hazards are present that could potentially cause harm. Methods include literature review, which involves examining existing research and data on known hazards. Field surveys, where we observe and collect data from the environment where the hazard might be present. Expert consultation, engaging specialists to identify and assess hazards. And finally, historical data analysis, reviewing past incidents and accidents to identify potential hazards. Hazard accounting. This involves quantifying the presence and concentration of identified hazards. The components include an inventory, which is listing all potential hazards in a given context, for example, chemicals in a factory. Quantification, which means measuring the amount, concentration, or intensity of each hazard. And sources and pathways, identifying where the hazards come from and how they might reach individuals or the environment. Scenarios of exposure. This is about determining how, when, and to what extent individuals or environmental components might be exposed to hazards. The components include exposure pathways, which are the routes by which hazards reach humans or ecological receptors, such as inhalation, ingestion, or dermal contact. Exposure frequency and duration, which is how often and for how long exposure occurs. And lastly, population at risk, identifying the groups of people or ecological receptors that are likely to be exposed. Risk characterization. This involves integrating information from hazard identification, hazard accounting, and exposure scenarios to estimate the risk. Now let's break this down into its components. First, we have risk estimation, which is all about calculating the probability and severity of adverse effects from exposure to hazards. Then there's uncertainty analysis, which assesses the degree of uncertainty in the risk estimates due to limitations in data or methodology. And finally, risk descriptions, providing a clear and comprehensive description of the risk, including potential health effects, environmental impacts, and affected populations. Risk management. This is the process of developing and implementing strategies to control, reduce, or eliminate identified risks. The components of this process include risk control measures, which involve implementing engineering controls, administrative controls, and personal protective equipment to mitigate risk. Another critical aspect is regulatory compliance, ensuring that risk management practices comply with relevant laws and regulations. Moreover, monitoring and review is essential, as it involves continuously monitoring the effectiveness of risk management measures and updating them as necessary. And of course, communication is key, informing all stakeholders about the risks and the measures in place to manage them. Key concepts in risk assessment. One important concept is threshold levels, which involves determining the level of exposure at which a hazard begins to pose a significant risk. Then there's the dose-response relationship, understanding how varying levels of exposure to a hazard affect the severity of outcomes. Another crucial concept is cost-benefit analysis, weighing the costs of implementing risk management measures against the benefits of reduced risk. And finally, life cycle analysis, which evaluates risks at all stages of a product's life cycle, from production to disposal. Risk assessment is a critical process for ensuring safety and minimizing harm in various contexts, including industrial operations, environmental management, and public health. By systematically identifying, accounting for, and managing hazards, organizations can protect people and the environment from adverse effects.